morning. Hope you can hear me and see the presentation file. Before beginning today's lecture, I just let you know that I have published your quizzes, short quizzes, okay? If you see something different or something typo, or you mean that some issues, feel free to email me, okay? Good morning all. And today we are going to start the lecture, chapter 11, that will cover reactions of alcohols. Reactions of alcohol mainly based on the oxidation, and we will be looking forward to this. So let's move on. So in this chapter, if we focus on what type of reaction done by alcohol, we can see here that dehydration of alkene, oxidation to aldehyde ketone, substitution to form alkyl halide, reduction to alkene, esterification, tosylation, and Williamson synthesis of ether. So today, according to our syllabus, we are going to focus on 11.1 to 11.4 and 11.7 if we have time to complete that. Hope so. Yeah. If you have any question, you can ask me because I can't see the chat box because I really prefer the full presentation so that we can see better. So feel free to ask me, and if your mic is not working, you can text me or ask me before the end of the class lecture. So let's see, here is the table. As we saw that this is the kind of reaction that can be normally performed by alcohol. Dehydration, by doing dehydration, product is alkene. By oxidation, product ketonaldehyde and acid. By substitution, aldehyde product. By reduction, alkenes. It also does esterification, esters, tosylation, tosylate ester, and also form alkoxide. So first, we need to make sure the language of oxidation and reduction in terms of inorganic chemistry and organic chemistry. In terms of inorganic or basic chemistry, we say that oxidation means loss of electrons and reduction means gain of electrons. And in the organic chemistry, what now we are studying, the oxidation means gain of oxygen or loss of hydrogen. Reduction means gain of hydrogen or loss of oxygen. I think in the last class, I also mentioned that you need to be always know and remember when we handle this type of topic. And there are some other type of reaction where there is no gain or loss of hydrogen, water, hydroxyl. These are neither an oxidation or nor a reduction. So there are some other different kind. Here we can see the arrow of oxidation and reduction. So we already learned that oxidation means the gain of oxygen and the reduction means the loss of oxygen or gain of hydrogen. So what is the oxidation state? Okay. Anybody can tell, do you know what is the oxidation state? Anybody know about the oxidation state? Do you want to share? Oxidation state is the number of elements that assigned on the basis of how many electron gain or lose during the chemical reaction. So that means when we will see the performance of the alcohol reaction, the number of electron gain or lose we represent at oxidation state, especially here oxidation state of carbon. And want to repeat last time here, the oxidation means the gain of oxygen and loss of hydrogen. Reduction means gain of hydrogen and loss of oxygen. You can see here the alkane. If it is primary alkane, first it will do the oxidation and from the primary alcohol. That means addition of oxygen. You can see here. If the continuous the reaction, it will further oxidation, do the oxidation. You can see the double bond. And remember, the oxidation means addition of oxygen in the same time removal of hydrogen, because loss of hydrogen. So you can see the first OH, but in the second time the hydrogen removed. So aldehyde. And if it is further oxidized, keep continue, then finally we will see the acid, carboxylic acid. In terms of secondary alkane, we will find the secondary alcohol and ketone. In that case, you can see that no further oxidation. Why? Because you can see that this is secondary alcohol, that means two alkyl group, and there is no more hydrogen left, because if you want to do oxidation, you have to look into the alpha carbon. Alpha carbon means when the carbon is directly attached to hydrogen and the functional group. So if you don't have any more hydrogen group, that means you don't have any more option to leave the hydrogen and add some oxygen. So therefore, for the secondary alkane, your oxidation will be stopped at the ketone. But if you look into now tertiary alkane, you can see that tertiary alkane actually normally, I mean, it's do the tertiary alcohol, and also to some extent, so bigger alkane, sometimes they don't do the oxidation too much because of the alkyl group. You can see here, this is not alcohol, this is alkane. So alkane to alcohol, and no further oxidation because of this alkyl group surrounding by the central carbon atom. So this is the basic. If you understand clearly, it will be helpful when we are going to move on to our next slides. So this way, that's why they give you two arrow. This way is oxidation, gain the oxygen, and if you opposite the way, lose of oxygen and add of hydrogen, then it will be reduction. Do you guys have any question here? Okay. So you can see here, let me let it down. So oxidation of secondary alcohol. Secondary alcohols we saw becomes ketone. Correct? This is our secondary alcohol, two alkyl group. And in most cases, when we performed oxidation reaction, we use lots of catalyst as a oxidizing agent. So traditional oxidizing agents are chromium-based reagents such as sodium chromate in sulfuric acid, and also active reagent is perchromate, or I mean chromic acid, or the ionized situation. Color change is orange to greenish blue. Chromium is highly toxic and difficult to dispose of properly. So that are the basic information about the oxidizing agent that we use during the oxidation, and normally we use traditionally or regularly we use chromium based reagents such as sodium chromate in sulfuric acid, and we will also see how it is made. So you can see that in the presence of the oxidizing agent, secondary alcohol convert to ketone. Now, if you look into the example here, we can see the cyclohexanol. So the hydrogen group leaves, and this hydrogen also leaves, and as a result here, the double bond forms, keto comes in the presence of the oxidizing group. Now, how we can make the sodium chromate, I mean, you can say the chromic acid. So how we can make it? The formation of acid chromate ion. So firstly, we start with the sodium dichromate. How it works actually. Sodium dichromate in the presence of water and sulfuric acid, it forms the chromic acid and leaves the sodium ion and bisulfate ion. And then that chromium trioxide react with the water. So if you have sodium dichromate, this will be acid, and if you have chromic oxide, it can also react with the water in presence of sulfuric acid, make the chromic acid, which ultimately form the acid chromate ion, since it can dissolve in water and ionize. So this is called the chromium trioxide will produce the chromic acid in presence of this sulfuric acid and water. By the way, I want to let you know that before the introduction we talk, that was the 11.1. Here we starting 11.2. See 11.2, just to make sure. Yeah. So the oxidation mechanism of acid. Here, I want to tell you something. As we already know, the oxidation state, which represents the number of electrons loss or gain. Now, oxidation means the gain of oxygen, correct? So, when we will talk the mechanism, in the same time, I will show you some example how easily we can calculate the oxidation state and prove that oxidation performed. So first, what happened actually in the mechanism? The mechanism of oxidation of alcohol involves formation of chromate state. Since we use this oxidizing agent very frequently, so our mechanism here we will explain on the basis of that. So first step is the formation of chromate star, and here you can see the water. This water group will be leave, and this chromate ester will be formed. And in the second step, the elimination step of the ester, chromate ester, and here when the chromic ester group will be leaving, you can look into here. Then since the oxygen is highly electronegative, so oxygen will take the electron, and here we will also leaving the water. So by this eliminating those things, here carbon will produce the double bond with the oxygen to maintain carbon's valence electron, that we know the 4 bond. And since we have the available electron from the oxygen, so that they will share and make this double bond. Now, this is obviously then oxidation happen, and this is at the group leaving, and this is also called the carbonyl carbon. So anyway, so this oxidation involves the two step. So first the chromate ester intermediate, and then the elimination of chromate ester and water will finally produce the oxidizing product. Here I also would like to mention that see the first step also eliminating the one molecule of water. Now how we can sure or calculate that during this oxidation number of oxygen is increasing or the electron is gain or loses. So in that case, we know the oxidation means gain of electron. So I'm not sure, you guys supposed to be study in your general chemistry course in the previous semester or before that. Mm, but I want to remind you, we can calculate the bond electron. I mean that, for example, the oxidation state of carbon, we have to use to calculate the number of electron loses or gain before or after oxidation by calculating the number of electron subtract to the valency electron of carbon. So we know the carbon valency electron is 4, and we have to subtract from the bonding electron of carbon. So next, let's open uh, one new slide, and I will show you that how we can calculate with one example. Here, let's write one primary alcohol. Sorry. Yeah, I opened this page because I also want to keep safe this presentation. That's why. Bear with the handwriting because I'm using my finger and pad. Yeah, and please if you have any question, let me know. My handwriting is bad, so I'm trying to write a little bit of nicely. So here we have the oxygen electron, and this is our, sorry. As we all know that if we need to do the oxidation, we need to make sure that carbon is alpha. This is called alpha carbon because it attached to the hydrogen and functional group. So now if we do oxidation, so what will happen here? Let's bear with me here example because you guys will be very clear and confident about this reaction after this example and explanation. So oxidation means the loss of hydrogen and gain of oxygen. So here we will lose this hydrogen, and as a result, this will be our product. I will just show you the one step for making you the clear. And if you have any question, let me know. Sorry. And if you can't hear me or something, obviously, oh, sorry. I don't need it. Just bear with me here. We don't need to write anything to write here. So since the hydrogen will leave here, carbon will make the double bond with the oxygen because you know oxygen is highly electronegative. Oxygen will take this bonding electron, and here they will utilize to make this double bond. Now, how we can calculate the oxidation state? As I say, the valence electron of carbon is 4. Subtract the bonding electron. Here is the things you need to know. I'm not sure if you forget. So carbon is bond here. Both are equal strength, so they will share one electron of this bond. And carbon and hydrogen, here carbon is more electronegative than hydrogen, so carbon will share the 2 electron. So now if we count the bonding electron here we have carbon hydrogen 2, here we have carbon hydrogen 2, 2 plus 2 4, and here they are sharing 1 each. So that means we have the 5 electron bonding. So that means here the oxidation state is -1. But now if we consider here, the formula is same. So the valency electron of carbon is 4, and how many we need to subtract with the bonding electron. So here how many we have, because here the oxygen is highly electronegative and oxygen take 2. So what else we have here? Here is 1. Oh, sorry, I did a mistake. I have to remove this. Yeah. So this hydrogen also go during the oxidation. Okay. Mm, no. I'm right. Sorry. It was my mistake. It's okay. It's okay. Anyway, so here I have the 1 electron. I think this hydrogen will not be here. 1 electron, 2 electron, 3 electron. Yes. So this hydrogen will not be here. I will make sure, yeah, this hydrogen will not be here. Will be leave during the oxidation. So here is the 2 electron and here is the 1. So this make the 3 electron, because when I try to calculate and make it from the source of my study material, it's correct. So here will be +1. So my purpose to show you here that when oxidation happen, oxygen is gained, and you can see, calculate the by measuring the oxidation state like that. So this is just a reminder, because this is not part of your syllabus, because we already completed in our past semester. So I just want to reminding you that this is how we can also calculate the oxidation state to prove that this is oxidation reaction, and oxidation reaction is happening. So try to remember. Now let's move on, and I will be cross check. I think it's correct. If I see something, I will let you know. So move on to the now mechanism. Next, so oxidation of primary alcohols to carboxylic acid. So if we have the, we saw that if we have the alkane, sorry, here alcohol in the presence of ester, how we can produce the oxidation and this alkene, the formation of chromate ester, we saw. Now we will see the oxidation of primary alcohol to carboxylic acid as an example. I think same example we also see here. See, similar kind of, yeah. So here it just finish at the ketone. Because, yeah. Now let's see. And here, when we will use the chromic acid reagent or sodium chromate in presence of sulfuric acid and cyclohexyl methanol will form the carboxylic acid. Remember that this reaction is a very fast and strong reaction. So in between, you can ask me that, Professor, you show that first the alcohol to aldehyde and then acid. So why here directly acid? Because some are so strong and so faster that we cannot stop at the aldehyde or that position. So the reaction goes very faster and it produces the acid. And this is the reason that cyclohexamethanol, hexyl methanol to cyclohexane carboxylic acid form under the condition of the oxidation when we use sodium carbonating acid. Pyridinium chlorochromate. Now let's talk about some additional oxidizing agent. As we saw, yeah, and this is 11.3. Okay, this is starting 11.3 according to our book and syllabus. So we saw that mainly or traditionally sodium chromate we use as a oxidizing agent in acid, and how the chromate ester form we also check it out. We also check it out, the mechanism is simple, and we also check how we can calculate the oxidation state to prove that your oxidation reaction performs. It's very easy. The valence electron subtract the bonding electron. And the bonding electron, we normally find the, there are two methods. Directly the number of bond, we can count the electron, and we saw that how we can calculate the, because we know that which one is electronegative, so how many bond is going to share. So we can subtract, and finally we got the oxidation step number. So here we are now talking about the additional oxidizing agent that also we used during the alcohol oxidation when we are talking about the chemical reaction or properties of alcohol. Here is one called the PCC, pyridinium chlorochromate. Pyridinium chlorochromate is a complex of chromium trioxide, pyridine, and HCl. So this is the pyridine, and this is the chromium trioxide, and it also, this chloride ion comes from the HCl. So this is actually the complex PCC. You know, I often during the lecture say that this one can be the important, this reason. I sometimes guide you the, study guide I share that how you should focus or how you should review or study. Today I was checking your book and I found that they also share the same strategy, especially the, when if we talk the mechanism of organic compound, especially different group like alcohol alkane. The reason is that if you focus on specific mechanism and try to remember, it's not so beneficial, because you saw that there are different types of chemical reaction. Some follow the rules, some have the extension of types and use and product. So this is better to focus on specific type of reaction and practice. It will be more beneficial for students or anybody who is interested in studying the chemistry. As I always tell you that chemistry have some rules but lots of exception. For example, I last time told you that when you practice the name of the reaction, um, always you need to practice and try to practice new, because you will see the different rules is coming or differences with the different structure, and this is the reason. So this is just a little suggestion or reminder that focus on the specific reagent, because that's very important. Different types of question come. Some reagents are very famous because reagents drastically change the reaction and product. So that's why reagents are important. So it's often come into the quiz exam also. So why I telling these things, because now we are focusing also on the reagent, and you can see that there is a one section they make for the oxidizing agent. So this is pyridium PCC. So that's also we use, and this is our structure. It mainly oxidizes primary alcohols to aldehyde. It also oxidizes secondary alcohols to ketone. Also remember, we talked in the beginning that tertiary alcohol normally doesn't do the oxidation because of all the alkyl group and lacking of hydrogen. So how it does? See here the primary alcohol. You remember I just show you the oxidation, and I told that this oxygen, yes, when oxidation happens, this hydrogen and this hydrogen leaves. So it's correct. Now see, same thing is here. So when you have the primary alcohol and this oxidizing agent, you will find the aldehyde. So they will leave this hydrogen and this hydrogen, because they are the strong oxidizing agent and they are highly electronegative. So by leaving this, the carbon will make a new bond to the oxygen is here. And you can see some example. You can also look into the books for a couple of examples. Next, that we know that tertiary alcohols cannot be oxidized, and here is the reason that I repeat. I think this is, I already repeat 2 times because this is the exception things and you need to be know. Yeah. So carbon does not have the hydrogen, so oxidation is difficult and involves the breakage of CC bond. Chromic acid test is for primary and secondary alcohols because tertiary alcohols do not react. Sodium hypochlorite is the another kind of oxidizing acid we use. Here, sodium hypochlorite, also we find in our household bleach, can oxidize alcohol without heavy metals or generating hazardous waste. Because sometimes if you look into here, when we are using some, like here, sometimes we have the metallic byproduct. So in that case, this is the advantage of this, of the using of this oxidizing agent, that it doesn't create any heavy metals or hazardous waste. And this is much better option than acid sensitive for acid sensitive compounds. So if we look into here, this hydrogen will eliminate and this bond will become, and the ketone will be our oxidation product. This oxidation name, according to the scientist whose name is Daniel Suren. I don't know how to sound this one, but this scientist name is Daniel, and I think this is his last name. But focus on the reason that this scientist use and name this oxidation. So this is also the kind of oxidation where we use the DMSO, dimethyl sulfoxide, with oxyl chloride. This is called the oxyl chloride, and hindered base. What is the hindered base? This is the base kind of for nucleophile. So proton removing base without any other function. So this kind of this kind of base is called the hindered base, because they are belong the pole nucleophile, and also we can use only to remove the proton, because oxidation means the removing proton and adding oxygen. Same straightforward talk. So there are so many agents, they have other action, so that creates the side effect or byproduct. So that's why this reagent is a great option altogether, because this only help to remove the proton and not any other kind of action. So we use this reagent and we can do some oxidation. Here we can see the alcohol to keto, and ultimately it will be aldehyde, because the 2 hydrogen will move here. Okay, so secondary alcohol to ketone and primary alcohol to aldehyde. If you have a secondary alcohol, it will be keto, and this is the primary, so it will be aldehyde. This is the another, as we said, that this we are talking here the additional kinds of oxidizing agent that we can use during the chemical reaction or oxidation of alcohol. Here we have the primary alcohol and DMP reagent. This DMP reagent is Dwes-Martin pyridine. This is also the based on some scientist. This reagent actually oxidize also the primary alcohol to aldehyde and secondary alcohol to ketone. And the DMP takes place under these conditions, so room temperature and neutral pH, because sometimes acidic and basic pH interfere the reaction, that's why. And this is the DMP reagent. So you can see how they help here to form the aldehyde, and how the reduced form of reagent come as a byproduct along with the acetic acid. We have some solved problem. You can see example cyclopentanol with this oxidizing acid cyclopentanone. Here, if you look into the oxidation is easy. If you look, you can do the product. But remember that what type of reagent is suitable in which situation, that you need a little bit of review. We also have here one. This is the DMP. This is the what type of, see, this synthesis require more fineness. The aldehyde is easily over-oxidized to carboxylic acid and double bond react with oxidants such as potassium permanganate. Our choices are limited to PCC or Schoren oxidation. So here are the condition. And when you study and review, this is always I am telling, because I know students forget and students suffer during the quiz. Take your books with you and take the lecture material and always check the what is the specialization of every reagent or reaction and what is their special feature or customized characteristics. Like if you look into for this reaction is custom special. That's why they mention here, because it has a double bond and alkyl chain. So, and also as we know, it is very difficult to stop the aldehyde because it continue oxidation and form the carboxylic acid. So our choice is limited and we can choose the selected reagent which can do the correct product. So we need to know that. So always focus on, always study like that, the way I'm explaining. That's this is the proven style of study. Now let's move on to the, so now till now what I want to just summary that till now we study that the how the alcohol oxidation happen, mechanism, how we can know the oxidation state to calculate. We also check different kinds of oxidizing agent and what type of reaction with that happen. And also we check it out till now the additional oxidizing agent we have and their specific feature. Now we are moving to enzymatic oxidation of ethanol. You can say this is kind of biochemical reaction too, because it also happened within our body. Because many people drink alcohol, you know that there is a common term that alcohol intoxication, because alcohol is toxic. To some extent, our body liver have the capacity to oxidize those alcohol to neutralize the intoxication. But when people drink too much ethanol, so liver cannot produce the sufficient enzyme to neutralize those ethanol by oxidation. Then people need to go to the hospital to clean up. So this is actually the fact when people drink too much, when they need to go to the hospital. So now let's move on our this oxidation. I want to just check the, okay, this is your 11.4 topic is started. So here, enzymatic oxidation, that's ethanol. This is the reduced form of ethanol, and we can see the alcohol dehydrogenase ADDase in the presence of this enzyme. So what happened actually here? To detoxify ethanol, as we say, the liver produces an enzyme that's called the ADase, alcohol dehydrogenase. So liver produces this enzyme and do the oxidation so that we can detoxify the alcohol, because ethanol will be no more, it will convert to acetic acid, and acetic acid is less toxic than the ethanol. This is the reason. Now, what we have in this structure, we are talking the NAD. So, alcohol dehydrogenase catalyzes this oxidation reaction. Here, removal of the two hydrogen atom, we can see here removal of the two hydrogen atom uh, from the alcohol molecule. And who does that? Here, NAD. This is NAD, nicotinamide adenine dinucleotide. So this one, with the help of this. So nicotinamide adenine dinucleotide. If you can see the two form of this is the oxidized form. You can see the plus sign. After completing this oxidation, this is the reduced form NADH. So with the help of this NAD oxidized form and the presence of the alcohol dehydrogenase enzyme, we can detoxify the alcohol by removing the two hydrogen proton. If this reaction continue, then from acetaldehyde to produce the acetic acid. And here, see the first one was the alcohol dehydrogenase ADH, and here the aldehyde dehydrogenase ALDH, and we use the same NAD. So the most important things we do this step because we want to detoxify, and this is also occur in our body as a part of our biochemical reaction. So that means the certain amount of alcohol consumption is okay because your body can produce the enzyme and do this reaction to detoxify. But if anybody drinks too much, then that's why we need the additional detoxification and need to go to the hospital. If you have any question, let me know. Biological oxidation of methanol and glycol. Okay, so here methanol oxidizes. Yeah, that's very simple. That when you will have a methanol, always the prime formaldehyde. When you will have a secondary acetaldehyde, if you have more, tertiary not work, so we don't need to talk that. So here, methanol oxidizes to formaldehyde and ultimately formic acid. And if you see the ethylene glycol, they form the oxalic acid. If you have a secondary, I think acetic acid. So this is you have to be remember when the biological oxidation of methanol and glycol goes on. Alcohol. Oh, okay. So now we finish the solve problem because in our syllabus, okay, so in our syllabus, we have a 11.1 to 11.4, and then we need to move to directly 11.7. Okay, so we don't have yet. If anybody interested, you can look into a couple of slides, but now we don't have. So I'm going to move to 11.7. So you don't need here. We will start from with HCl. Yeah. Reaction of alcohol with acid. Yeah, the reaction of alcohol with acid. It will be because then we need to explain the substitution 1 and the substitution 2 reaction. Yeah. So this is our 11.7 starting. Okay. Just to make sure. So now let's move on here. We already know that alcohol leaving the proton and adding the oxygen, but this is we have by two kinds of substitution when this kind of reaction is performing by alcohol with acids. So in that case, our product will be alkyl halide. Okay. This is we finished the last part. So this is the new another part. So this group of reaction involves two types of mechanism: substitution reaction 1 and the substitution reaction mechanism 2. I just want to do a little bit of brief. This brief you don't have in the in your slide, so you can just I mean review from yeah, you can just review what I'm talking now. So substitution reaction is actually the two-step reaction. Substitution 1, I will come back here. So this is the substitution 1. This is a two-step reaction. So carbocation forming and the bromide atom. So, but substitution 2, SN2 is single step reaction. Substitution 1 reaction, why this is named substitution 1? Because total reaction is depend on the concentration of only one reactant or substrate. However, if we look into the substitution 2 reaction, we will see they depend on the two types of reactants. For example, if we consider substitution reaction AB plus C, so the product might be final AC plus B. So here that means this substitution 2 reaction depends on the concentration of two reactants. That's why they name it. But they need only single step because of the this nucleotide is very strong. So this is the basic things you need to know about the substitution 1 and 2. That why it's named substitution 1, 2, because this is called the unimolecular. Unimolecular means that depend on only one reactant, okay? And the substitution unimolecular. And substitution 2 is the bimolecular, depends on the concentration of two reactants. And in addition, SN1 mechanism involves the two-step and SN2 mechanism involves the one-step. So this is, you need to know as a basic of this mechanism that you don't have in your slide. Now let's move on. Sorry, come here. So the hydroxy group is protonated by an acid to convert it into a good living group. So that means the hydroxyl group can be protonated and we can live as a water. Okay, as a water we will leave it. So they are actually the good living group. Once the alcohol is protonated, a substitution or elimination reaction can take place. So this is our two conditions. First, we have to be protonated and make the good living group, and second, we have to have substitution or elimination for the final product. Reaction of alcohol with hydrogen bromide. In that case, what we are finding? Obviously, the living group, the hydroxyl group will go and this kind of reaction here happens. This will be living group as lead, and since this is highly electronegative, we already know, we talk lots in the alkanol. That's why you will now feel these chapters are friendly, I mean not any challenging things. So they will make a add here. So this is how this bromocyclohexane will be found. So OH of alcohol is protonated, and OH2 or H2O is a good living group, and tertiary and secondary alcohol react with. You need to remember, because this kind of question is very famous question and frequently asked question. I mean, this is the main reaction of alcohol, correct? So see, tertiary and 2-degree alcohol react with bromide ion via SN1. Primary alcohol react via SN2. So this is the first special feature you need to know. So now let's talk about the mechanism. What happened here? So first step, protonation and create the good living group. Second step, formation of carbocation. And this formation of carbocation, this step is very slow step, and their reactivity like tertiary, secondary, and reactivity range, tertiary, secondary, and primary. So actually what happened? We know that carbon and oxygen both are electronegative, but oxygen is highly electronegative than the carbon atom. So what happened when the oxygen, I mean this living group, see this green are living group, when they leave, obviously they take this electron. So when they take this electron, it forms the carbocation as an electrophile. So they want to look into the strong nucleophile. As we already know, the nucleophile have a excess electron that can be donate who need the electron and make the bond. So this is how the alkyl bromide will be formed. So the reaction reactivity, if we consider here, so the third degree, 2 degree, the 1 degree. Okay, so this is the mechanism. So this one is the fast step, and this is the slow step, but this is the very fast step means experiment reaction done very fast. I meaning so. But total is here, and you can see the step one protonation, making the good living group. Second step formation of carbocation, and last step bromide attacks the carbocation and form the alkyl bromide. So this is the substitution one mechanism. This is very important part of this chapter. Do you have any question? Let me know. Anybody have question? I want to ask. Do you guys have any question here? Okay, I'm sorry, I cannot see the chat box. So maybe after lecture I can check it out. If you want to text your question, no problem. So I want to revise here one more time. The substitution one reaction, the name because this is unimolecular. However, the mechanism involves the multiple step, two step mainly. Substitution reaction is called the unimolecular because it depends on the concentration of one reactants. Okay. So normally we saw the tertiary and secondary alcohol react with bromide or halide mainly, but bromide is actually very famous and work faster through the SN1. And primary alcohol will react similar reaction but SN2 by the SN2 mechanism. What we saw in the mechanism here, that first step the protonation to make a good living group, second step formation of carbocation, and third step attacking carbocation by bromide and nucleophile. And finally, the alkyl halide will be our in this particular case, tert butyl bromide or alkyl halide will be our product. And the substitution 2 mechanism, here we are see that this is 2 because it depends on the this reaction depends on the concentration of the both reactants, like that we can see here. Second, we saw here that this is the direct fast step, one single step reaction and a straightforward reaction. How? Sorry, I don't know. Can you see and hear me? Because my place seems that it's little bit of hanging, like I'm not sure, but yeah, okay, now it's fine. So in the kind of substitution 2 mechanism, we can see that they directly, nucleophile directly attacks the substrate as the living group. So that means here you don't need to be prepared the good living group or protonation. Here directly the nucleophile attack here and they will leave the living group and they will add nucleophilic addition. So bromide ion will be added here. So whatever in the substitution one, we saw the step by step, but in case of substitution two, we will see the single step and straightforward. And this will be here. And when the, if you look into here, when they will attack, obviously here the old bond between the HBr will be break and and bromide will take it, and that's why here you could see the oxygen ion positive because they're looking for the electron. So that's why this bromide will come here. See, look into here. That's why it will come. Eventually, this will come. Yeah, that's why this will come here, and it will live as a H2O. It will live as a H2O. And when it will leave, oxygen is electronegative, so then the carbon. Now you can take, yeah, because oxygen is also electronegative, carbon is, but oxygen is more electronegative than carbon, so oxygen will take this bonding electron. That's why here you can see the neutral water molecule as a byproduct. So this is the mechanism of SN2. I hope there is nothing complicated anymore and you understand here. Now let's see what we have. You can, even if you need to see a little bit more, you can check it out the book. I following your book completely. So yeah, I mean, I have my own, as you see that with the other book, but I'm following the syllabus, and I don't want you to confuse. I gave some materials as a support in the beginning because you needed those, but I really don't want to make things complicated. So I'm 100% now following our books according to our syllabus. So I must say here that you guys have uh, couple of example in the book in this SN1 SN2 chapter. Please look into, and now we will also be talking some important reaction SN1 that's using the Lucas reagent, zinc chloride. So let's find out what we have. So we saw the bromide 1 and SN1, SN2. So let's move on. We will find the Lucas reagent, of course, here. So chloride is weaker nucleophile than the bromide because it is small and less polarizable. Addition, yeah, this is, see, we find it. So addition of zinc chloride, which bonds strongly with the oxygen of hydroxyl group, promotes the reaction. Lucas test, this is very famous, yes. SN1 reaction. So Lucas test, zinc chloride in concentrated HCl. Primary alcohol reacts slowly or not at all. Secondary alcohol react in 1 to 5 minutes, and tertiary alcohol reacts in less than 1 minute. So if we consider the reactivity, you can see the tertiary is more faster than the secondary. Secondary is more faster than the primary. Yeah, sometimes you may see this type of question. I am actually facing the problem when I'm typing the editing the reaction on the canvas, especially the answer option. I do not have too much option and format is changing so drastically. Actually, I need to help to get some software. I will ask the department. That's why there are some questions I want to ask you, especially the mechanism related, but I could not ask you because of this my limitation. So yeah, but I think you are doing homework, so you will be fine on that. So kinds of these kind of things we are talking here. So let's move on here, how we did this reaction with the Lucas reagent. So if we do the Lucas reagent with the, with the SN2, this is very slow reagent, slow. But SN1 do very fast. So let's look into. And the mechanism is kind of similar if you look into here. When the chloride ion is attacking here through the SN2 reaction, what is going on? Because here the partial positive and negative charge, carbon forming negative, and here is partially positive due to the distribution of the electron. And here we can see this is the leaving group. So when oxygen will leave, then oxygen will take the electron because oxygen is more electronegative than carbon. As a result, a carbon will make the new bond with this chlorine is here, you can see. And other than that will be remain. And this will be the transition state. However, this reaction is very slow. And primary alcohol react with Lucas reagent by the SN2. Reaction is very slow. The reaction can take from several minutes to several days. Yeah. So primary alcohol work through this, but secondary and tertiary, now let's see. As I said, see, the SN1 reaction with the Lucas reagent is very faster. So when we do the SN1 mechanism with the same reagent, we can save the time, and by following the similar mechanism, protonation, good living group, and then attack the nucleophile, formation of carbocation, and then attacking the nucleophile is here. Limitation of this reagent. Four yields of alkyl chloride from primary and secondary. Elimination completes with substitution. Carbocation intermediate may undergo rearrangement. Limited ability to make the alkyl halide. So though this reaction have potential application, in the same time, these are the limitations. Sometimes it is important to know as an exam material. So look into the limitations. We have here to solve problem. You guys can check it out. Yeah. Now reaction with phosphorus halide. If you have any question, let me know. Actually, we already done today's job. So today's lecture, according to our syllabus, was 11.1 to 11.7. So I think now today, every day we go very tight. So today we can stop here and we can take the question and we can little bit of talk here first. Why it's not stopping? Do you guys have question? Now I will take your question. Any question? As I said, I have published your quiz. On the last three chapters, 6 short quizzes, each worth 50 points, and you have 40 minutes for each quiz. No need to hurry. First two chapter, 4 quizzes. I gave you the deadline September 30, and third chapter alcohol unit, chapter 10, what we have, the 2 short quizzes, I gave you 3rd October. I am thinking that after alcohol, I will continue, but I will suggest Dr. Gaun to have our first examination on the basis of the first 4 chapter. That means till this chapter. So do you have any suggestion on that? Why I cannot stop it?